Okay, let's see if this works. Oh.
Okay, start.
Okay. So, hey everyone. I'm Alejandro Martínez. I'm a systems engineer at CartoDB. And I wanted to give this talk. This is about the CartoDB Basemaps, a tale of data tiles and dark matter sandwiches. And after all, it's a tale, or like a story, of how we ended up serving basemaps by just an evening hack of a co-founder of Sergio, which tried to do something. And on Friday evenings, we have something that we call the Leapfrog Fridays, which is basically we devote the evening to spending some time hacking on top of the CartoDB stack for some experimental stuff or things that we want to improve or feed a little bit more in the stack. And we do this a lot because we like to push our own limits, and it's our way of development. We build a lot of the CartoDB stack, a lot of the new pieces, on top of the existing pieces of the CartoDB stack. For example, the geocoding is just SQL functions on top of a CartoDB account, which have all the related data and use their own post-RESTful search capacities to search around for geocoding names and polygons. Or the data library datasets are built, if you log into your CartoDB account and go to create a new visualization, and you got a lot of open data that you can use out of the box, that data is actually fetched from another different CartoDB account, which is serving the data, and it's being copied to your own account. And also a lot of internal APIs and things we use both for development or in the systems team or for everything are built on top of the CartoDB because we think it's a way to sort of improve the experience, both for us and for everyone who wants to build things on top of our platform. So back to the basemaps. A basemap is simple and yet complex. I mean, a simple basemap is just a layer of data. In our case, we want it to be some open data and with a matching style, which is most of the times is the most difficult thing. So it makes sense for an evening to try to create some basemaps using CartoDB. Even though CartoDB, since the beginning, it wasn't envisioned as a platform for making basemaps, but for putting layers of information on top of basemaps, like overlays of data, of quite a small amount of data compared to OSM or compared to any other data that might be worth to be called a basemap to show information on top of. But most of our stack was already based on PostgreSQL, PostGIS, which happens to be like the most common stuff for serving basemaps itself, even though we've focused a lot of serving dynamic data that changes frequently and is not as big as the data set from OSM. We believe it could be worth a shot. So we went working, and we obviously went with a less detailed data set, which is natural Earth, and got all the polygons and related things to make a bare basemap, which is not even province level, just countries level, and try to style it a bit. And we did like 3 to 4 basemaps using the own CartoDB editor with a big account and data we uploaded using the CartoDB UI. And we use this to try to explore how far did we get on our purpose of being a data visualization overlay, some kind of specialists, from how far we were from being a basemap editor. And we were almost there. I mean, you could make a basic basemap using CartoDB with just uploading the data sets and making the styling, which can get to be really tricky and difficult as you deal with different zooms and things. But we found that the CartoDB editor was not the best suited tool for this because of, well, starting for the UI, I mean, the UI wasn't designed to suit such a big amount of layers, one on top of each other, and there was a point when they overlapped each other and it broke. And some other things like the data set size, I mean, you could upload data sets of 2 gigabytes, 3 gigabytes tops, but that's not that. If we wanted to make a worldwide data set, we could not import it using the CartoDB UI, and that was fine because you usually don't want to upload and display a 100 gigabyte table at once. Basemaps are the exemption for us, not the rule. But yeah, despite of all these hurdles in the editor, making a simple basemap was quite easy, and it was simple to make it work because CartoDB, the tiler, already serves XYZ tiles, but it does with this code. We call this a layer group ID, which is something that depends on both the time the data sets have changed and the style, but we didn't need that because we wanted to get a fetch URL, so we did the quick route, which is just make a route and make a rule and nginx to just make a fixed URL pointing to the real one for the visualization. And that was the easy way to have, I mean, we already had something that you could use as a basemap simply on leaflet without even using CartoDB JS or any tool that accepted XYZ format for serving basemaps without very much work. So achievement unlocked, like we got the first basemap. And we've had the basemap, we launched those simple basemap like a year and a half ago, I think, a little bit more maybe. And they were already available in the CartoDB editor for a long time. But then almost a year ago, we wanted to go a bit further. We wanted to go a bit further because we wanted to remove the map views limiting, because if you want to make social maps and maps that get shared by the community, and like getting people to make maps without being afraid of how many times will we they viewed, and they want to make them actually want them to be popular, we had to remove that restriction and make all the maps in CartoDB have unlimited map views. But then we had the data that is overlaid, but then we also need something unlimited to put behind. And we tried, of course there are a lot of people serving basemaps that do very much better than us, but we wanted to give it a try and to make an OSM-based basemap that we could host ourselves and that we could be the responsibles of, and we could pay like the usage of it. And that also was designed for data visualization, in the sense that this basemap is really going to be the default basemap in the CartoDB editor. So 100% or up to 90% of the usage is going to get is from visualization that made on top of it and data that's overlaid. So we wanted to be as close to data visualization as we could. So that's why we decided to cross the OSM limits, and we got the help of Omniscale to using Imposum, make a definition that makes sense, and having the whole OSM inside a table, which happened to be inside a CartoDB database and inside a CartoDB account. And we got a select all from Planet with all the geometries in OSM that, well, it doesn't make sense. It doesn't make sense to query a 150 gigabyte OSM data with only PostgreSQL for data rendering, but we have it there and we could like do stuff on top of it. And then to cross the matter limits, this is a bad pun because of the name of the basemap, like a matter, we got the help of a statement which helped us make two awesome open source basemaps, which is positron and dark matter, the white and the dark one, which were designed with data visualization in mind, as in they're the ones which are going to be using CartoDB by default, so they better be. And that's how we got a bunch of interesting stuff on top of the already imported OSM to handle the zooming and visualization on top of, while inside the CartoDB platform and our existing basemap infrastructure. For example, we used materialized views to filter the sections of OSM that were going to be relevant at its zoom to avoid like transferring too many data to the tiler server. And we use materialized views because they're very handy, and PostgreSQL 9.4 they can be refreshed concurrently. So it made sense to use them as some kind of mirror of the OSM data that we keep updating with imposing and osmosis with the filter data for the base map. And also a lot of SQL magic to make sure that the data matches its zoom, etc. And this was done by the awesome Gaussian statement, both with which helped us doing all these things. And then we also got to the development process, which was a bit. We started developing the base maps using TileMill, which it also uses CartoCSS. It pretty much matched what we wanted to display. But then we found some issues with the CartoCSS handling. Is slightly different from the one on our CartoDB map APIs. So we decided to just look for something else. And while the initial development was done on TileMill, we went iterating and did another draft editor, which was made on HTML with just CartoDB JS. But we ended up with creating another cool way to edit base maps on top of CartoDB, which is the Atom basemap editor, which is not really a basemap editor per se, but it's a plugin you can put on top of Atom, which just will connect to your CartoDB account and allow you to easily edit some CartoCSS and automatically push it to CartoDB and have a preview window to display the data set you've shown and the visualization you're creating. So this is it, and it's cool because you can just change anything. For example, I'm going to change the water color because water is like blue, don't you think? So with a bunch of cool plugins for editing and linting and Carto editing on top of Atom, we felt it was like the right ecosystem to fit in, and you just save, and it automatically gets pushed to CartoDB, and it generates a new base map with the style you've sent. And you can also not only change the style, which has its own hierarchy and variables and any custom CartoCSS common things, but you can also change the queries that are applied to the map and to each layer. So you can, like for example, I just opened a new one, apply any kind of queries. For example, this is a cool example I got, that you can just apply an ST transform and have the same map dynamically rendered and reprojected into another projection. This is Robinson. So another advantage of this is that all the base maps are rendered using our existing infrastructure, which is focused on dynamic mapping and making sure that things get updated quickly. So you could also mix on top between the layers of that base map. You could also mix your own data sets or your own information that you can keep updating using the CartoDB editor, the SQL API, of whatever way of accessing CartoDB you want to use. And you can use them inside of base map, either masks, overviews, filtering using SQL, or any kind of combination you want to achieve, as you're pretty much editing the SQL and CSS, and we're just rendering. And we also have all the caching mechanisms and invalidation mechanisms, both with our local vanish, our CDN, which is Fastly, to make sure it will keep just updated in almost real time. So we kept experimenting on these base maps and developing new features that I'm gonna go through briefly. And the first one is sandwiches. Sandwiches in the sense that our base maps were, as I already said a couple of times, were thought for data visualization. And with data visualization, you often get things like this. This is like a map that is all, the transparency it doesn't have very much transparency, so it's covering all layers. So what do you do? Well, it's quite simple. It sounds quite simple, but it has a little slice of complexity. You can just put the labels on top. So what it is we release another, as the Basemaps project was quite structured in layers, we just released another different layer, which was just a layer which only had the labels on top, so you can just put, using leaflet and CartoDB JS, put the base map, which is the thing you see behind the blue mass. On top of it, to put wherever you want to visualize, and on top of that, you put the labels. And it makes for a nice visual change. It's a little small detail, but this affected a lot of pieces on our stack. Even though we had a bit of styling issues, like, well, you have to alter the style and adjust the labels, but it was pretty simple to make it. But we also went and implemented some other things all over the CartoDB, which ended up exploding and affecting a lot of pieces of our stack, because right now the CartoDB editor is using the sandwich labels by default without telling you. And most people didn't even notice, which I think is pretty cool, because it feels like natural. We also implemented some quite things in our tiling server to be able to cope with all of this. And one of those is, you see those preview basemaps? Those preview visualizations on your basemaps, on your maps, sorry. The previews were actually on the first iteration of the editor when they're using leaflet, and they got all the 3 layers. But we wanted to go a step further and be able to serve just like an actual image for your whole visualization, including the base map and the labels and, of course, your data. And we went over this by using the Maps API that we already have, which is based on WinShaft, which is based on Mapnik, and it's called WinShaft, adding what we call the sandwich mode, which basically means that you can no longer only request Mapnik layers with style and CSS and queries, but you can also request an HTTP layer. Any HTTP layer that allows XYZ. For example, in this case, it's our own base map. But you can put pretty much any other base map on it, and it will request all the layers and compose them together and serve them as another map, which is just like a combined version in PNG of that map. And another thing we added for the dashboard is that you're no longer confined to request XYZ tiles, but you can also request, we also the static map API, which means that you can request, give me this tile for a fitting zoom and center in these coordinates and of a given size. And you can just alter in the URL, the parameters that you see here on the end, you can just change and tweak the map where you want to display it. So, the last part is the systems part that I'm most involved in with, because the base map, during the development of the base map, we ended up improving our infrastructure by load testing and comparing and new settings and exploring new things that we ended up testing with the base maps, but expanding to the whole CartoDB. The first of them is meta tiling. Meta tiling is a simple concept, which is that the tiling server, which is the one that serves the tiles, when you ask for a tile, instead of rendering just that tile, it renders for example, if you want to request this tile, it will not paint this tile, but also paint the whole adjacent, a bunch of adjacent tiles, and have them saved. So, because you know, most of the times it's going to be people seeing a huge map and requesting a lot of tiles. So it's kind of intelligent to reduce SQL queries to just paint a bit, assuming that the user will request it. Metatiling is handled by WinShaft, by tile like Mapnik, in fact, on an internal cache. So when you request a tile, it automatically generates the adjacent tiles. But the problem with our existing stack is that our stack is more or less like this, the overall stack of the CartoDB system, or software as a service system, which is that we didn't only have one tiler, but we had more than one tiler, and we balance amongst them using another upper layer, which is not here, which is Nginx, which by default the routing that we'll use is quite stupid in the sense that it will be just a round robin and randomize the request along all tilers. But the problem when you have that is that when you request a tile to a tiler, that tiler will paint all the adjacent tiles, but that tiler will not be served with will not serve the adjacent tiles, because round robin will probably serve it to another one. So we'll just end up painting like 4 times the amount of tiles that we wanted to paint for nothing. So we went exploring and hacking around, and we found a very interesting way to do this, which is consistent hashing, which is like just each request is assigned like a hash that will determine which server will serve it. But with Nginx and OpenResty, which is a Lua environment put on top of Nginx that you can use to hook into requests, you can decide what can you use to calculate the hash on. So we went and after some exploring, we came up with this simple piece of code. We'll just do some math operations, given how the quad tree works, to make sure that all the tiles that have the same, that are contained into the same meta tile for the same zone are served by the same tiler server. So it's kind of not optimal routing for the distributed environments of serving tiles. And then again, the last thing we've done to play with this more, for squeezing all the performance out of the serving, was ditching WKV. WKV is the default transport format for PostgreSQL, which is uses an 8-byte float for each coordinate of its position. For example, imagine that you have a polygon with 800 points or corner vertices. It will transfer each of those vertices with approximately a precision of that. I usually never have that precision. I mean, you don't usually have subatomic precision in your CartoDB visualizations. If you do, then you're cool. You're the coolest man I've ever met. But we decided to explore how could we change this, and we ended up with something what we call tiny well-no binary, which is a specification that we open source and we want to build upon. And we work with some other people to do this. And it's equivalent to that well-no binary, but using delta encoding and variable precision to make sure it fits the more or less the precision that you want to display in a tile, because usually you don't want subatomic precision for displaying a 256 or 256 tile. Usually, with having in which pixels or pixel is the point is enough. And well, I got another talk about this in a later session. But tiny well-no binary basically helped us really squeeze a lot of performance for this and get a huge performance improvements. Because network, in this case of Basemaps, was one of our main bottlenecks. And we just, moving to tiny well-no binary, I think you can guess on this graph when we moved, reduced to our overall traffic to 10% of what it was on the traffic between the database server and the tiler server. So, yeah, this is how evening hack ended up like destroying and causing improvements all over the stack. And that's all. I think I made it better. So if you have any questions, thank you.
Any question and comment? To decide.
No questions?
No? Okay, thank you, sir.
Welcome.